Solution for our last question for today. Okay. Okay, it says a 500-gram block of copper. Alright, so that means the mass of copper, MCU, is 500 grams. And this is given in terms of grams, right? So we have to convert to, I think, okay, no, let's leave it in terms of grams. Yes, let's leave it in terms of grams, alright? Since the specific heat capacity of copper was given in terms of grams, and the mass also in terms of grams, there will be no need here converting. Okay, there will be no need here converting. This is one thing I usually say. Before you start to even convert, always check for if there is a constant in that particular question. Alright, if your constant is in the unit of a particular quantity mentioned, you leave it like that. Alright, as you can see here, the specific heat capacity of copper is given as joules per gram, okay, and the mass is given in terms of grams also. So we'll just proceed like that. Alright, so the mass of copper is 500. Then okay, this copper was raised from an initial temperature. When the heat was applied, it moved from 20 degrees Celsius to a new temperature of 80 degrees Celsius. When the copper was heated, it moved from 20 degrees Celsius to 80 degrees Celsius. The specific heat capacity of copper, that is my CCU now, is given to me in this question as 0.385 joules per gram per degree Celsius. Alright, and we are told to calculate the amount of heat energy transferred to the copper block. The amount of heat energy transferred to the copper block is simply the heat quantity of the copper block. And we know the formula very well, MC delta theta. Okay, so this is the amount of heat energy transferred to the copper block. So let's get the value. H will be equal to the mass of copper is 500 times the specific heat capacity of copper is 0.385 times what temperature change did it undergo from theta 1 to theta 2. So this will be theta 2 minus theta 1. So it will be 80 minus 20. So 500 times 0.385 times 60. So let's do that mathematics. Punch your calculators with me. So I have 500 times 0.385 times 60. So the heat energy is giving us 11,550 joules. 11,550 joules, or if I convert this to kilojoules, it will be 11.55 kilojoules. So this is the heat energy that was supplied to the copper when its temperature moved from theta 1 to, from 20 degrees Celsius